Point estimator is the function of the data drawn from the random process. This makes point estimator a random variable, and as with any random variable, they have some expected value. This leads us to the notion of the bias of an estimator. Let's say that theta is the true value of the parameter and theta hat is its point estimator. Since the difference between the true value of the parameter and the expected value of the point estimator is known as bias. However, if the bias of an estimator equals 0, it is said to be an unbiased estimator. Or, if the bias goes to 0 as the number of data points approaches infinity, it is said to be an asymptotically unbiased estimator. Let's now do an example where we evaluate the bias of an estimator. Let's say we have m data points drawn from the Bernoulli distribution with mean theta. For an estimator of the mean, we will use the sample mean, which simply is to divide the sum of the data points by the number of data points. To evaluate the bias of this estimator, we need to find its expected value. So let's substitute theta hat with sample mean. Now, data point is the only random variable here. The expected value of the distribution and its mean are the same, so we can substitute the expected value of the data point with mean. As a result, we will find that sample mean is an unbiased estimator.